Okay, today I will teach topic bearings regarding the course design of machine elements 2. Myself, Ram Prasad, Assistant Professor, Department of Mechanical Engineering. These are the 5 outcomes for this course. Select the suitable bearing based on the application of loads and predict the life of the bearing. Design of IC engine parts. Third one is the design of power transmission elements such as gears, belts, chains, pulleys, ropes, levers, and power screws. Design spur and helical gear for different engineering applications. Fifth one is the design of machine tool elements. These are the 5 outcomes. These are the textbooks we are following. Textbook is V.B. Bhandari and V.B. Bhandari, machine design by V.B. Bhandari and V.B. Bhandari, machine design, and N.C. Pandya and C.S. Shah, machine design. Reference books we are following is R.S. Kurmi and J.K. Gupta, machine design, and R.L. Norton, machine design. These are the 2 reference textbooks and 2 prescribed textbooks we are following. Here for this subject, we are allowing design data book is permitted for this course in the final examination as well as the mid examination. And these are the references we are following. NPTEL 2 references are there, and third one is the textbook, and 2 YouTube links I have given. Next, these are the 5 units. Unit 1 is the bearing, second one is engine parts, third one is the power transmission of pulleys, design of power screws, fourth unit is the spur and helical gear drives, and fifth one is the machine tool elements. Unit 1 is a bearing. A bearing is a machine element which supports another moving machine element known as journal. It permits a relative motion between the contact surface of the member while carrying the load. A little consideration will show that due to relative motion between the contact surfaces, a certain amount of power is wasted in overcoming the frictional resistance. And if the rubbing surfaces are in direct contact, there will be a rapid wear. In order to reduce frictional resistance and wear, and in some cases to carry away the heat generated, a layer of fluid known as lubricant may be provided. The lubricant used to separate the journal and bearing is usually a mineral oil refined from petroleum, but vegetable oils, silicon oils, greases, etc. may be used. Classification of bearing depending upon the direction of load to be supported. Here, first one is the radial load and second radial bearing, and second one is the thrust bearing. In radial bearing, load acts perpendicular to the direction of motion of the moving element, whereas in thrust bearing, the load acts to the axis of the rotation. And these bearings move in either direction. You see in the diagram A, B, and C. A and B are the radial bearings, and C is the thrust bearing. Okay. Next, second one is the depending upon the nature of contact. The bearings under this group are classified into sliding contact bearing, and B is the rolling contact bearing. In sliding contact bearing, the sliding takes along the surface of contact between the moving element and the fixed element. The sliding contact bearing are also known as plain bearing. In rolling contact bearing, the steel balls or rollers are interposed between the moving and fixed elements. The balls offer rolling friction at 2 points for each ball or roller. Types of sliding contact bearing. The sliding contact bearing in which the sliding action is guided in a straight line and carrying radial loads as shown where may be called as slipper or guide bearing. And such type of bearing are usually found in crosshead of steam engines. Okay, next, crosshead of steam engines. First one. Next, the sliding contact bearing in which the sliding acts along the circumference of a circle or an arc of a circle and carrying radial loads are known as journal or sleeve bearing. When the angle of contact with bearing with the journal is 360 degrees, then the bearing is called full journal bearing. Full journal bearing is a clearance bearing, whereas partial journal bearing is also a clearance bearing, but angle of contact between the bearing and the journal is here is 120 degrees. Whereas for full journal bearing it is 360 degrees. Whereas fitted journal bearing is also 120 degrees, but no clearance is provided. Therefore, it is called as a fitted journal bearing. Okay, fitted bearing. Here, journal and the bearings diameters are equal. And the sliding contact bearing, according to thickness of layer of the lubricant between the bearing and the journal, may also be classified as thick film bearing, thin film bearing, zero film bearing, and fourth one is the hydrostatic or externally pressurized lubricated bearing. Okay. First problem is design a journal bearing for a centrifugal pump from the following data. Load on the journal is equal to 20,000 newtons. Speed of the journal is equal to 900 rpm. Type of oil is SAE10 for which absolute viscosity at 55 degrees centigrade is equal to 0.017 kg per meter second. Ambient temperature of oil is equal to 15.5 degrees centigrade. The maximum bearing pressure of the pump for the pump is equal to 1.5 Newton per mm square. Calculate also mass of the lubricating oil required for artificial cooling if the rise of temperature of the oil be limited to 10 degrees centigrade. Heat dissipation coefficient is equal to 1232 watt per meter square per degree centigrade. Given load is equal to 20,000 newtons, RPM is equal to 900 RPM, T naught 55 degrees centigrade, Z is equal to 0.017 kg per meter second. Ambient temperature is equal to 15.5 degrees centigrade. Pressure is equal to 1.5 Newton per mm square. T is equal to 10 degrees centigrade and C is equal to 1232 watt per meter square per degree centigrade. Here, this problem is related to centrifugal pump. In data book, you have to choose along with the centrifugal pump data only. There you have to see the L by D ratio, C by D ratio, Zn by P value, pressure, everything you have to see from the data book. So that here for centrifugal pump, the ratio L by D varies from 1 to 2. So let L by D is equal to 1.6, you take L is equal to 1.6D, that is equal to D. If you take 100, then 1.6 into 100, that is 160 mm. So D is equal to 100 mm and L is equal to 160 mm. Pressure is equal to load by area. Load means nothing but L into D. Load by area. Area is nothing but L into D. So load is 20,000 divided by 160 into 100, that is 1.25. So here Z is given 0.017 kg per meter second into N is equal to 900 divided by pressure is equal to 1.25 from the data book. That is equal to how much you are getting, 12.24. So totally how much you are getting, 12.24. From table Zn by P value is 28. So if you calculate like this, from how much you are getting, we have to equate this 28 to 3K. So 3K is equal to 28 means K is equal to how much? 9.33. 12.24 is more than 9.33. Therefore, the bearing will operate under hydrodynamic conditions. Previously, we calculated pressure is equal to load by area. That is how much you are getting, 1.25. It is give more than the 1.5 that is given. So therefore, the value of P is safe and hence the dimensions of L and D are safe. Okay. Now you see from table C by D is equal to 0.0013. If coefficient of friction mu is equal to 33 by 10 power 8 into Zn by P into D by C plus K. You're getting 33 by 10 power 8 into 12.24 into 0.1 by 0.0013 plus 0.002. You are getting 0.0051. Heat generated is equal to mu WE. Mu how much you are getting, 0.0051 into W is equal to 20,000 into pi dn by 60. This pi into D is equal to 100. You have to take in meters per second. So 0.1 into 900 by 60. You are getting 480.7 watts. So heat dissipated is equal to Ca into Tb minus Ta. So C is equal to how much you are getting? C into area is equal to L into D. So how much you are getting? 1232 into L is equal to how much? 0.16 into D is equal to 0.1 into T naught minus TA value is TB minus TA value is equal to 19.75. So you are getting 389.3 W. So TB minus TA is equal to nothing but the formula is equal to 1 by 2 into T naught minus TA. So operating temperature is given 55 minus ambient temperature 15.5. You are getting 19.75. Now totally you are getting heat dissipated is equal to 389.3 W watts. So how much artificial cooling is required? Heat generated minus heat dissipated. So Qg minus Qd, you are getting 91.4 watts. So next we have to calculate mass of the lubricating oil required for artificial cooling. Q is equal to MST. So Q is equal to MST means M into S is constant, that is 1840 to 2100 joule per kg per degree centigrade. So M into 1900 into 10 is equal to 19,000 M. So Q is equal to 19.4. You are getting M is equal to 0.0048 kg per second. That is equal to 0.22288 kg per minute. The load, second problem, the load on the general bearing is 150 kilonewton due to the turbine shaft of 300 diameter running at 1800 and determine the following. Length of the bearing if the allowable bearing pressure is 1.6 Newton per mm square, and here pressure is given, bearing pressure 1.6 Newton per mm square. Second one, amount of heat to be removed by the lubricant per minute if the bearing temperature is 60 degrees centigrade and viscosity of the oil at 60 degrees centigrade is 0.02 kg per meter second, and the bearing clearance is 0.25 mm. These are the given. So here you have to calculate heat generated is equal to mu W. For that you have to calculate mu, and next you have to calculate area. If pressure is given, how much it is 1.6 Newton per meter square. Pressure is equal to load by area. Load is also given 150 into 10 cube. Area is equal to L into D. Here diameter is given 300 mm into L. That you have to find. L is equal to 312.5 mm. Now amount heat to be removed by the lubricant mu is equal to 33 by 10 power 8 into Z1 by P into D by C plus K. Here 33 by 10 power 8 into 0.02 into 1800 by 1.6 into 300 by 0.25 plus 0.002. So finally you are getting here 0.0011. Bearing clearance is given, C is given how much? 0.25. So D by C you are getting how much totally? 0.0011. Here velocity is equal to always in meters per second. So pi into 0.3 into 1800 by 60. You are getting 28.3 meters per second. Q, amount of heat to be removed by the lubricant is equal to mu WV. So mu is into 0.011 into 150 into 10 cube into 28.3. That is equal to 46,695 joule per second or watts. That is equal to 46.695 kilowatts. The general bearing 60 mm is diameter and 90 mm long runs at 450 rpm. The oil used for the hydrodynamic lubrication has an absolute viscosity of 0.06 meters per second. If the diameter clearance is 0.1, find the safe load on the bearing. Given D is equal to 60 mm, that is equal to 0.06 meters, L is equal to 90 mm, 0.09 meters, N is equal to 450 rpm, that is Z is equal to 0.06 kg per meter second, C is equal to 0.1 mm. So for this you need Sommerfeld number. So that is equal to Zn by P into D by C whole square is equal to 14.3 into 10 power 6. So Z value is 0.06 into 450 by P into 60 divided by 0.1 whole square is equal to 14.3 into 10 power 6. You are getting P is equal to 0.68 Newton per mm square. P is equal to 0.68 Newton per mm square. Load is equal to pressure into area. Pressure into L into D. So pressure is equal to how much you are getting 0.68 into length into D. So L is equal to 90 and D is equal to 60. So that is equal to 3672 newtons. Okay. Now, in rolling contact bearing, the contact between the bearing surfaces is rolling instead of sliding, as in sliding contact. For this, metal to metal contact will occur with high coefficient of friction. Whereas for rolling contact bearing, there is low starting friction. Due to this low starting friction offered by rolling contact bearing, we are calling it as a anti-friction bearings. Okay. In rolling contact bearing, the contact between bearing surface is rolling instead of sliding, as in sliding contact bearings. We have discussed that ordinary sliding bearings start from rest with practically metal to metal contact and has a high coefficient of friction. It is an outstanding advantage of a rolling contact bearing over a sliding contact bearing that it has low starting friction. Due to this low friction offered by rolling contact bearings, these are called anti-friction bearings. Advantage and disadvantage of rolling contact bearings over sliding contact bearings. What is the advantage? Low starting and running friction except at very high speeds. Ability to withstand monumental shock loads. Accuracy of shaft alignment. Low cost of maintenance as no lubrication is required while in service. Small overall dimensions, reliability of services, easy to mount and erect. Eighth one is the cleanness. These are the main advantages. What are the disadvantages? More noisy at very high speeds, low resistance to shock loading, more initial cost. And last one is the design of a bearing housing is complicated. Type of rolling contact bearing. Following are the two types of rolling contact bearing: ball bearings and roller bearings. The ball and roller bearing consists of inner race which is mounted on the shaft or a journal, and an outer race which is carried by the housing or casing. In between the inner and outer race, there are balls or rollers. A number of balls or rollers are used, and these are held at proper distance by retainers so that they do not touch each other. The retainers are in thin strips and is usually in two parts, which are assembled after the balls have been properly spaced. The ball bearings are used for light loads, and the roller bearings are used for heavy loads. The rolling cotton bearing, depending upon the load to be carried, are classified as radial bearings. Second one is the thrust bearings. Radial bearings means these are the types of radial ball bearings. And first one you see ball bearing